Now let's get right into it. After all, C++ is an object-oriented language, so it's about time we started handling C++ objects. For that, we're going to introduce a new syntax, new keywords. And I think that if you've been following the PHP Piscine closely, you're already familiar with some of these keywords, syntax and notions. Otherwise, let's take a moment to rediscover them. Here I've written two files allowing to declare a new class on one side and to define this class on the other. I'll get back to it in a moment, but I'd like to start by a little aside on the naming convention I use and would like to share. Here you can see that the declaration of my class was placed in a file I named sample.class.hpp, sample with a capital S. It's the nomenclature I'm using. Here's how it works. As the name of my class is sample with the first letter capitalized, my file name starts with this name. Then to be sure I'm dealing with a class, I use the .class pre-extension. That will allow me to filter my files more easily in the terminal to find out whether I'm dealing with a class header or a header for something else. Then I use the HPP expression to define my C++ headers. In C, you use the .h extension. I prefer to use .hpp, but I'm absolutely not imposing you this. It just happens to be more practical, so your text editors can use the right mode. If you use the .h, chances are your text editor sees your file as c.h and not a C++ one. .hpp solves this. But then, you may reconfigure your text editor yourself. I have no problem with that. So whether you name your file sample.h or sample.class.hpp or sample.class.h or whatever the combination may be, I don't care at all. I'm just asking you is to be coherent and consistent in your naming convention. You pick one and you stick to it. In the same way, I'm naming my corresponding source file as follows: the name of the class .class.cpp. In the same way, you're free to name it the way you want. I just happen to like that naming. I think it's explicit. Zaz would tell you it makes him want to throw up, but that's up to him. Everyone has his own style. Let's start by declaring a class in C++. It all happens on this side of the terminal, where you can see that the class keyword is used, followed by the identifier that will then allow us to identify this class, this new type, this new data structure. We add in a pair of curly braces, and don't forget to finish them with a semicolon. You'll most likely happen to forget the semicolon. It won't compile. You'll be presented with very long, complicated messages, indicating errors in areas of the code that have nothing to do with it. The first thing you need to check is whether you added a semicolon at the end of your class. It's stupid, but it happens to everyone, so be careful with this. You can see here that I added a public keyword. We won't worry about it for now. We will see in a future video what it means, but you might have already guessed. Then we have these two particular lines. These two lines will allow me to declare a constructor and a destructor for my class. For this, C++ uses the name of the class for the constructor and the name of the class preceded by a tilde for the destruction. But the tilde is actually part of the name of my class, destruction function. I'm talking about constructors and destructors. But what are these? It's just that when my class is instantiated, as we'll see in a moment, the construction function is called. When the instance of the class gets destroyed, the destructor will be called. To make sure of this, we're going to write some code, as we can see on the other side of the terminal, where I'll show how to define the functions present in my class. Here we can see that I declared a constructor named sample and not accepting parameters. Here in the sample class, I want to access the sample function, which constructor is here. Note the syntax that should remember you of something. It's indeed the same syntax as namespaces. You'll notice that between classes and namespaces, there are a few interesting relations. I'll talk more about this because it's a topic I'm passionate about. We can see that I define my sample constructor of the sample class, not accepting parameters, and the code of this constructor will just output constructor called on the standard output, followed by a carriage return. Then we return. You notice that there's absolutely no return type, not here nor there. It's just because constructors and destructors of C++ classes don't have a return type. They are producers, so we could see it as a return void, but it's not actually written. It might seem strange to write this, but the constructor and the destructor don't have any return type. However, I may write return to show that I'm done writing my constructor or my destructor. If you forget it, it would work the same way. But I think it's better to show that you're done writing your code. The code of the destructor works exactly the same way. On my standard output, I want to output the destructor called string followed by my carriage return. It couldn't be any simpler. Now let's see how to create an instance of my class. It's done in a way you're already very familiar with, since the syntax is quite similar to C, consisting in writing. Just type space the name of the instance. It's pretty much like declaring a simple variable. And with this simple line, I will have a variable named instance of the sample type. So the instance variable will be the instance of the sample class, right? The class is the static part. What you have described, the written code, it's a model. The instance will be the dynamic part. It's the same principle as the baking mold and the cake. Your mold is the class from which you will be able to make many distinct cakes. They will be instances made with the same mold, cake instances. Here I name my variable instance, which might be confusing. I should have named it differently because the instance variable is an instance of the sample class, instantiating my class this way. I will automatically call the constructor. This simple line will have two effects. The first one will be giving me variable of the sample type, a class instance, and in the second one, the code that was in constructor will be run. Then, as you know, coming from C, when we're out of the scope of a function, all of the local variables are destroyed. You probably remember it works exactly the same way here. When I'm done executing my function, main brackets in this case, but it could be any function, all the local variables are destroyed, especially my instance variable. And if you're not too dumb, you're probably thinking that it's at this moment that the code of the destructor is run. We haven't seen yet how to create dynamic instances on the stack. Think about malloc brackets and free brackets in C. C++ offers other mechanisms, but you'll see that it also allows to call the constructor during the instantiation and the destructor during the destruction. To see by ourselves, our simple this example is, let's compile it. Here, our compilation was successful. Let's run the code. We can see that as expected, the code of the constructor was called, then the code of the destructor was called too. Nothing very complicated in this video. What you should keep in mind is the notions of class, instance and definition and declaration. In our .h or .hpp, we'll be able to declare the class and the functions and attributes it contains. Then, in the .cpp, we'll be able to define these functions present in our class. We'll see that they are member functions, using a syntax similar to the namespaces. Now I'll let you meditate on all this, and I'll see you in a moment for the next video.